И мы снова в эфире. Напоминаю, что если в трансляции вы не хотите слышать переводчика, а хотите слушать голос докладчика, то кнопка переключения языка
We are
находится
back
справа
online.
в панели.
I
А у нас
remind you that
следующий
you
докладчик
have a
это
button
Роб
on the
Аллен,
right
который
and of your
расскажет нам
player
про
to switch
Serverless PHP.
languages.
Привет, Роб.
And Rob Allen, who will talk to us about serverless PHP, is with us. Hi.
Hello.
Расскажи немного о себе, чем ты сейчас
Will you
занимаешься.
talk to us, please, about yourself? What do you do?
Hi. So my name is Rob Allen, and I'm a software developer. I'm a consultant. I do a lot of PHP. I've been doing PHP for a very long time now. I started in 1999. That's how long ago it was. PHP 3 was current when I started. And we're now about to get PHP 8. It's been an amazing change over my time. And one of the areas that has changed since I started was that we no longer have computers under our desk running our websites. We can now put them on the cloud, and serverless is going to be the next big thing for the way we host and build our applications. It's what I'm interested in. I like doing APIs. I think this is the future.
Расскажи, что тебя привело к этой теме.
Will you talk to us, please, more about how you came into this topic? Was it a professional interest to check what PHP can do, or some specific task that you had at hand to solve with serverless?
Well, yes. So serverless is interesting to me for a number of reasons, but professionally, I had a problem where we had very bursty traffic. So we had traffic where we had nothing to do for most of the time. And then we had a very small period of time when we had to do an awful lot of work in a very short length of time. And we looked into scaling up servers in order to run them for 6 hours and then shutting them all down again, and dealing with all the management around managing the EC2 cluster to handle this very large amount of work that only happened for 6 hours once every 30 days. And then I discovered that serverless does that automatically for me. It does the whole concept of scaling out your workload automatically to as many servers as we need, up to about 1,000 or so, plenty. And I didn't have to do any of the management work. Not only that, it was really, really cost effective. I couldn't think of anything that wasn't bad about this. This was a great solution to my problem. The only issue was that there was no obvious PHP solution for serverless. Everyone said JavaScript, JavaScript, JavaScript. JavaScript is a fine language, but all our business logic is in PHP. So I wanted PHP on serverless. So I looked around, found an open source project called OpenWhisk, and contributed PHP to it, and then was able to move forward from there. So since then, I've been very interested in PHP on serverless. I think serverless is really important, and I think everyone should know about it.
Wow. And what do you think, why most cloud providers, or many cloud providers, don't support PHP out of the box?
Now, there's a good question, isn't it? I think, well, the support has got much better, to be fair. But PHP is no longer a cool language in the same way that something like JavaScript is, or TypeScript, or something like that. Because it's been around a while, it gets its job done really, really well. And it's quite mature, it's quite stable. New versions of PHP don't break the world anymore. We've got quite a good thing going for ourselves now. But it is not so exciting, I suppose, as maybe some of the newer languages. And an awful lot of people start in PHP. So if you look at the vast majority of developers out there, they've all done some PHP. An awful lot of them did that PHP a long while ago. PHP was less good a long time ago. It's much better nowadays. So you have a group of people who have their opinions about PHP that are a bit in the past, a bit old-fashioned, and they shape their decisions based on that. And we see that quite a lot in other ecosystems where they make assumptions about PHP that are wrong. They make no sense. But that mindset just pervades still. So I think it takes a while for the tech teams in other technologies to get up to speed with understanding that PHP is still a massive ecosystem and is still going places.
Спасибо за ответы, ты прям заинтриговал. Что ж, давай послушаем твой доклад.
Thank you indeed for your reply, and you really did intrigue the audience, so you have the floor. Let's go to have a look at what you have to present.
Exciting. Hey everyone. As we've already heard, I'm into PHP. I've been into PHP for a long while. I've done serverless for a little bit. I'm very much an API developer, so most of what I'm going to talk about is in the context of APIs and HTTP APIs. I'm not very good at building the front end of websites, so HTML, CSS, not me, definitely not me. PHP, backend, definitely me. So that's what we're going to talk about today, how serverless fits into the ecosystem of development and how PHP works on the serverless platforms. So let's get started. So where I want to start is, what is serverless? This is a fantastic quote by Paul Johnson. A serverless solution is one that costs you nothing to run if nobody is using it, excluding data storage costs. So what we're saying here is that we can have compute power that we only pay for when we are actually making money from it. And I think that is really, really powerful. I think it is very, very good. I think it is helpful for us to be able to align the way that we are developing and making money from our applications with the way we are hosting them. And serverless is one of the better ways to actually do that. Now, serverless is quite a general word. I appreciate that. So what we have is a number of as a service type things that all can be considered a serverless type solution. Someone else is doing the work for us. Storage as a service, database as a service, authentication as a service, etc. And the one that we're talking about today is function as a service. This is when we have our code. We deploy it to the cloud, someone else's server. It runs only when needed. It scales automatically, and we pay only for execution. This is the proposition. It's not particularly complicated, but it is just our code running on someone else's server when necessary. So let's talk through some use cases. So firstly, synchronous. Service is invoked and we get an immediate response. So an API request. Send a request into the API, get a response back from the API. Chatbots work the same sort of way. The Echoes and the Google Assistants, those sort of things, are all synchronous situations. Then we have asynchronous. We push a message, the work happens later. Webhooks are a good example of this, or cron jobs, or something happens in the database and then we need to do some work. Those sort of things are asynchronous and also work really well. It's not a silver bullet. There's a very tendency in the tech world that when something new comes along, we sell it as the greatest thing ever. And we're software engineers, we're developers. That's not the truth. Not everything is suited for every solution. And there's always situations when it doesn't actually fit. So what about serverless? What are the challenges and the areas where maybe serverless doesn't fit so well? So let's quickly look through those. First one is startup latency. Your code only runs when necessary. As a result, it takes time to get started. We call that the startup latency. It's not very long. It's measured in hundreds of milliseconds. But if that is a problem for you, this is not the solution for you. Similarly, there's a time limit. You cannot run your code forever without interruption. Serverless doesn't work like that. If you have that sort of problem, that sort of requirement, this is not the solution for you. The average serverless platform will let you run your code for between 10 and 30 minutes. If you need your code to run longer than that, use something else. This one comes up a lot. State is external. And as a PHP developer, you don't care. This is not really a problem for you because you are used to it. Every other web development language doesn't work the way PHP works in terms of handling state. And what I mean by state is I mean global variables of settings or stuff that you can keep in memory from one request to the next request. In PHP, we never ever do that because we have a setup, run our request, tear down, approach to our code. So we never keep a variable in memory from one request to the next request. We always put our state externally. We always store session data onto files or onto Redis or into APC or whatever. Other languages don't work like that. They just stick it in memory, it stays in the application server, and is just there for the next request. So other languages have to struggle with this when they move to serverless, which behaves a lot like PHP behaves in terms of every single request is isolated from another one. I put it here though because it will come up a lot. When you talk about serverless, people will talk about external state being an issue. For PHP, we don't care. It is a different way of thinking though. We are thinking about code that is split up into lots of different functions, behaves differently. We move the boring work to external providers. We think far more commodity based. We put our database into the cloud. We put authentication somewhere else. We store our files in S3. We start spreading things out and thinking about the way we organize our application a little bit differently when we're thinking serverless. And that requires a little bit of mind shift change and not quite so easy to just use serverless in the best way it can be used. But most of all, it's about value. I think this is mostly interesting by far because of the cost proposition. You only pay when your code is running. I think that is really, really vital for understanding why serverless is so popular and why it will become more and more popular. And this set of tweets from Bo quite clearly emphasizes this, particularly that last one. We're relearning what was known in the timeshare days. Pricing needs to be based on something that the customers value, not on infrastructure. And that's what serverless is all about. We are pricing based on when our code is running, when it is doing something positive for our customers. So when should you use serverless? Obvious ones to start with. If you've got a webhook, that's a great thing to stick a serverless function at the end of. Get it hooked in and nice and isolated. Webhook comes in, do some processing. Nice and quick and easy. If you've got a PWA or a static site that you need a little bit of compute power for, like processing a contact form or something similar to like that, then a serverless action works really, really well for that too. Additional features on your current platform. Maybe you get into the limits and you now need a new bit of functionality and it's going to need another couple of servers stood up, something like that. Stick it up on serverless. Don't worry about changing all your current code. Just build the new functionality on top of serverless into your application. That's a great way to start using serverless in the real world. You've got variable traffic levels. It's a case I talked about earlier. When your application does next to nothing and then needs to do quite a lot of work for a short period of time and then goes back to doing nothing, that sort of scenario, serverless is really cost effective. Automatic scaling helps very, very much for those sort of scenarios. Costs are scaling with traffic. That is a key feature. More traffic, more costs. If you can turn more traffic into more money, then we have a nice, easy relationship between making money, having more business, and our costs going up. And it's a nice scaling system. So that sort of scenario is also a really good position to put your serverless code, that sort of thing. Serverless platforms. Where can you run serverless nowadays? All the big players are using it. You've probably heard of them: AWS, IBM, Google Cloud, Azure. They're fairly big. Microsoft isn't a small company. Cloudflare is using it. Startups like Nimbella are using it. And then at the bottom, I've put 3 open source solutions as well. So we have FN, we have OpenFaz, and we have Apache OpenWhisk, are 3 open source serverless platforms that you run yourself. And there are a number of big multinationals that are doing just that. These are the ones that use PHP, or that you can run PHP on. That's pretty impressive. Straight out the bat, the vast majority you can run PHP on. This wasn't necessarily true 3 years ago, but it certainly is true now. You'll notice I've put a dotted line around Google Cloud Platform. The reason for that is that their PHP support is still in alpha or beta. It's very much not production ready yet. It will become production ready, but not quite there yet. But they are certainly on the path. But that's a lot of PHP support now. If you've got PHP, you want to run it on serverless, you have choice. I'm going to start with Apache OpenWhisk. I will admit to bias at this point. Apache OpenWhisk is open source. I like open source. I think open source is a good thing. I write and help maintain open source packages like the Slim framework. I think it is a useful thing for our community. So OpenWhisk suits me in that sense. Also, I'm a contributor to OpenWhisk. That means that I have added source code to OpenWhisk, and in particular I have added PHP support to OpenWhisk. So clearly quite biased. I think it's quite good. Apache OpenWhisk is supported by multiple corporates: IBM, Adobe, Red Hat, Nava, people like that, all using Apache OpenWhisk. Supports lots and lots of languages. And you've probably seen or heard of most of those. But obviously the one we care about today is PHP. So let's talk about how PHP works on a serverless platform. We're going to use OpenWhisk because it's open source, so it's easier to talk about because we know what's happening. This is what an action looks like. This is our PHP source code. We have an entry point. Our entry point is called main because in time immemorial, main has been the entry point to your application, all the way back to C. Our function takes a list of parameters. We call them the event parameters. That is all the information needed to execute this particular request. And then we've got a standard application. So the first thing we're going to do is handle our inputs. So our arguments contains a bunch of things. We have parameters that are set at deploy time or on the invocation. We have runtime stuff in there as well. We're going to pull that out into our application. We're going to do some work. This is obviously where we do our actual application logic. This particular example does next to nothing, of course. It's a hello world application. And then finally, we need to render our result and return it. So a serverless application returns its data from its functions and then the restless system worries about sending it down to the rest of the world, sending it back to your client. So I simply return an array, and JSON goes back down the line, or HTML, or whatever we need to send. It's command line based. So the WSK is the name of the executable. It's pronounced whisk. So whisk action update. Hello is the name of our function. Hello.php is our source code, and it will update this action called hello for us. Update, create are basically interchangeable. If the hello action doesn't exist, it will be created for us. And then we can execute it. To run our function, we use the word invoke. We invoke a action. Always invent new words for the same thing. That's what technologists do. So whisk action invoke hello -- result means that it is a synchronous action or synchronous invocation. I want the result to come back immediately. So -- result, get the result back, hello world. As I say, it's JSON by default, which suits me very much because I'm into APIs. How did it do that? One of the nice things about this being open source is that we can look under the hood and see how OpenWhisk does it. And all the other systems work basically the same way. The defaults change, not quite the same, but fundamentally they all work like this. We have some sort of input, Nginx in this case. This is our front end. So everything that comes into OpenWhisk comes in as an API call. We have a controller that does all the marshalling and all the work. That's written in Scala. We have a data store, CouchDB in this case, a queuing system, Kafka, and then we have an invoker which does the work. So the invoker starts up a container, and then your code runs in the container. That's the basics of what OpenWhisk looks like. When we create an action, we send a post request to the controller. The controller puts the action code into the database. And that's all. Nothing else happens. So it's very, very simple. Most importantly, it does not check your code for correctness when you create your action. That code could be rubbish. Nobody would know at this point in time. We've just stored it into the database. When we invoke it, that's when we find this out. So in invocation, we do another post to the controller. That sends via the queue a request to the invoker. The invoker gets the data from the database. And what it does is it puts your source code into the action container on the init request. Once the source code is in the container, it then runs the source code by calling the run action, the run post. Data comes back from the action, it gets put back into the CouchDB, and then it is sent back to the controller, which sends it back to the client. That's what happens behind the scenes. So what about that container itself? The action container holds your code. It has two endpoints, init and run, as we said. So firstly, we start the Docker container running. Once it's running, we post the init endpoint, which loads the source code. And then once we've got instantiated source code, we can run that source code again and again and again and again and again, as often as we like. Eventually, we no longer need to run that source code anymore. We can run it a few times. We will throw the container away. That startup time is called the cold start time. From starting Docker through to being able to execute our source code, actually run it, is the cold start time. And that is our startup latency. You'll notice it only happens on the very first instantiation of the Docker container. Once the first request has gone in, every subsequent request is faster because we don't need to start the container every time, because we can run the same source code multiple times. That's it. Now you know all there is to know about the basics of how serverless actions are executed within the system. We could turn it into an API. With OpenWhisk, we just add the web flag. Action update hello, -- web true, and now we can use curl. We get a URL and it's automatically generated for us, so it's not very pretty. We get our response back. There's something called an API gateway. All the major providers have an API gateway, which enables you to do more with your HTTP endpoints. You can route endpoint methods to actions. You can have a custom domain. You can do rate limiting, etc. This is where the cleverness happens. And invariably, if you are doing public-facing serverless, you will put an API gateway in front of your actions because it enables you to do the custom domains and do the smarts. Highly recommended. If you're just doing something like a webhook or a Echo chatbot type thing, then just use the native built-in thing. On OpenWhisk, it's just fine because it doesn't really matter what the URL looks like. But if you're public-facing, use the API gateway. Looks like that. There's our client, there's our API gateway, there's our OpenWhisk. API create /demo /hello get hello will create me an application called demo, define an endpoint called /hello, which will accept a GET request. Nice and easy. And of course, we can curl to it with a far nicer domain name. ow.acrobat.com is my custom domain name attached to this API gateway. Let's look at an example. To do backend, I can't show you my actual source code that runs on OpenWhisk because it's a client project. So I'm going to show you a example that I built to show how it worked. To do backend is an open source project that shows you how to build the same API in multiple different platforms. So there's examples written in different languages, examples written with different database technologies, examples written in different hosting environments. So I wrote one to show you how to build this same API, the to-do API, in OpenWhisk using PHP. This is what it looks like. It's a sort of very simple application architecture diagram. We have our client, talks to our API gateway. We have 4 actions: create to do, show to do, update to do, delete to do, with various HTTP methods attached to each one, and they all talk to a Postgres database. So there's a Postgres database in the cloud holding our list of to-do items. We're going to use Serverless Framework. In order to manage and maintain all the actions that we have created, so we're going to create multiple actions, multiple blocks of source code in our whole application that we now need to manage and deploy up to the OpenWhisk environment. We do that via tooling. We could use our command line. We could do it all individually, one at a time in our command line, but we're not going to because that is tedious. It's error prone, and I am against making my life hard. I like my life to be easy. Serverless Framework is a deployment tooling system for serverless applications. It enables me to define all the actions, all the resources that my application will have, and it will manage deploying the source code up to OpenWhisk for me. I like this a lot. Other benefit, of course, I can put this file in version control, which means that I can have versioned deployment, and I appreciate that as well. In my YAML file, to define a particular action, I do this. We call them functions. I give it a name, edit -to do, and then I give it the actual information. When the edit to do action is invoked, please run this file, edit to do.php, the main function within it. Obviously, I give it a name as well, so that I can reference it within my within my API gateway. Then I've got my API gateway itself. I can manage and define how this particular action will be invoked from the web. It's an HTTP event, and it has a path and a method. So this one in particular is for editing a to-do item. So its path is going to be /todos/ID, and ID is a placeholder. And the method is going to be patch, because that's the specification for this particular API. Project files look like this. We're now looking at a fairly standard PHP application. We have a source folder. We have a vendor folder because we are using Composer. And we also have our serverless.yaml file because that's our deployment system. Source directory looks like this. We have a to-do folder. The to-do folder is a namespace, like every other project that uses Composer, which holds the business logic for this application. And then we have the list of actions, which very loosely map to controller actions within a framework like Laravel or Slim framework or something like that, where I've got my add to do, my delete to do, edit to do, etc. And I also have a DI container called app container. This is edit to do. It's not very long. It's about 33 lines of code. Now, I appreciate that you have got a high resolution monitor and you maybe can read that if you squint. But it's a bit too small, isn't it? So let's look at each bit in turn in a bit more detail, nice and large on the slide. Here's our main function. First thing we do is have a try catch. We want to catch any errors and we want to handle them appropriately. Always put in good error handling in your applications. I don't care what type of application you're building. I don't care how you're deploying it. Make sure your error handling makes sense. Don't just dump HTML to an API client. In OpenWhisk, anything you var dump goes into the logs because we send back what we want to send back to the client. Everything else just goes to logs. So I can just var dump out my output and it will go into the logs so I can decide and help work out what's gone wrong. Then I have to return something back to the client. In this case, I'm going to send an error code between 400 and 500, and I'm going to send back the error message. So now I've got a fairly nice, very simple, fairly nice error handling. It will send back the right status code. It will send back a body with some information about what went wrong. All covered. Then we do some work. We're going to grab the input from the arguments. OW path will hold the information to get us the ID. Then we're going to get the data, which will be in the body because this is a patch request. So I can JSON decode it. And now I've got the data to actually update this to-do item. Any problems, going to throw an exception. Then I go do the work. That's what I'm doing here. Grabbing the to-do mapper, which is where my business logic lives. That's in this section here. And then I can load it. Well, I could, but there we go, the button didn't work. So I load the data from the database, update it with the new data, store it back into the database. And then finally, I can send my results back. I use a PHP league component called Fractal to do that work for me. So that's what's going on here. There we actually use a Fractal component to create an output object. And then I can return the output object as an array so that it gets turned into JSON and sent back to the user. All done. Serverless deploy will deploy this up to the cloud for me. It whirs away, packages everything up, sends it all up, deploys it nicely for me, and I have a working application. So that's the fundamentals of how we build applications in OpenWhisk. It's just PHP code. That's all we're doing. Now, I think OpenWhisk is quite a good system. I like it a lot. It's runnable in public using something like IBM or Nimbella. They both use OpenWhisk behind the scenes. It's also used for a number of private companies as well, so it's fairly popular. You're probably not using IBM Cloud though, are you? What are you more likely to be using? I think you're more likely to be using AWS. Maybe not so much in Russia. I don't know what it looks like over there. But certainly when I talk to a large number of developers, they have all heard of Amazon. AWS appears to be fairly popular. And they did invent serverless after all with Lambda. So how do you do it in AWS? Let's quickly look. First thing to know, AWS Lambda and PHP was only possible since 2018 because that's when they introduced something called layers, and where you can create a layer with the PHP executable and then you can write your PHP function. Don't do that though. It's already been done for us with this project. Bref makes running PHP on AWS Lambda simple. It's a great project by a friend of mine called Matthew, and he does all the work to maintain the PHP runtimes for Lambda. He makes deployment easy using Serverless Framework, and it has great documentation. So this is how you do PHP on Lambda. Instead of creating the main function, you create an anonymous function that you return. It still takes your event parameters. So it's very similar in the way it works to OpenWhisk. And to be fair, all the other languages, all the other serverless frameworks too, serverless providers. We still have a serverless YAML file, basically the same. One difference is we have to tell it that the runtime is provided and which runtime we want to use. So here we're going to use Bref's PHP 7.4 runtime. And that's how Lambda will know that we run in PHP. Obviously, PHP 7.4 is the one everyone should be running today. Index.php is the name of the handler for the hello function. So it's nice and simple in this case. And then we can actually get the work done. Hit serverless deploy, sends it up to the cloud as before, and we can run it using serverless invoke -f for function, hello function, and it returns back hello world. You can also pass in parameters, so we can send back hello Rob or something like that as well. One nice thing about using Bref and AWS Lambda is that they have a Docker solution as well, so you can run it locally for testing. I like that. I think that's quite helpful. Xdebug also works this way, which is even more helpful. Very, very big proponent of using Xdebug to help you develop and make it work right. AWS Gateway. What happened there? There we go. AWS Gateway, the API gateway, we can add by adding HTTP events in the same way as we do for OpenWhisk. So here I'm responding to get hello or get /hi. And if we're going to do an API, we use a PSR 15 request handler, where we create a handle function and we return a PSR 7 response. So that's all very, very standard PHP at this point. And Bref takes care of making it all work with Lambda. Obviously, deploy works exactly the same way as you'd expect, but this time you get an endpoint that you can use. Again, not very pretty until you put in your custom domain. But you can test it, and using curl, you can see we get hello Rob back as we would expect. So doing it on AWS, pretty much the same as doing it on OpenWhisk, doing it on Google Cloud, same thing. Doing it OpenFaaS, very, very similar. They're all basically the same, which makes life quite easy. So lastly, I'm going to quickly show you through a real project on AWS Lambda in PHP, which is Project 365, which is a photo a day website. I take lots of photos, I put them up on Flickr, and then I want them in a nice little website showing just the photos, one per day. And that's what this project does. It's a static website hosted on S3, uses CloudFront CDN, and uses Lambda PHP. So it's all about AWS functionality. We have a scheduled task, a cron, which runs our Lambda function. Our Lambda function will fetch the images from Flickr. It will then store an HTML page back to S3, and then it will clear the CloudFront cache so that CloudFront can then serve the HTML web page. So we're building a static web page using PHP as a clock, picking up data via an API. Again, it's simply configuration. So I'm not creating an API gateway this time, I'm creating a scheduler. So I'm going to create a schedule with a cron rate of once every 2 hours. Again, it's going to be talking to index.php, and my main function looks something like this. Quite a lot going on in there. We get some data out of the event data, so we pick up which year we're building the page for, so 2020 at the moment. Then we use a page creator to create to get the data from Flickr and create the HTML. So that's fine, that's good. In a separate file, in a separate class, because we're just building PHP code at this point. Then we're going to upload it. So we have an uploader class that's going to upload the data to S3 for us. And then once it's done that, it's going to invalidate the cache for us. So I'm encapsulating my business logic somewhere else, because it doesn't have to be within serverless. That code is reusable. I'm a big fan of reusability. Actual code itself, not particularly complicated. I'm using Guzzle, the underlying HTTP client, to talk to Flickr. Flickr's UI is a little bit weird, not the best API, I suppose, but it works. So I get back JSON with the photos in it, so that's quite nice. You can see that here. There's the URL I need to create. That's not going through. There we go. Then we actually send the request, we get the data back, and then we can upload it to S3. An S3 client is part of the AWS PHP SDK. They make it really easy to work with PHP with their services. It's a very nice ecosystem. So once I've got my S3 client, I can just call put object. And I've now uploaded my HTML file into the S3 bucket. I haven't showed you how to make the HTML file because practically my HTML isn't very good. You don't want to see it. Invalidation of Cloudfront works exactly the same basic way. We have the Cloudfront client, part of the S3 SDK, and then we create an invalidation for it and tell it which particular file we want to delete, 2020.html in this case. And that's it. We have a website. I particularly like this photo, which is why it's the one I show from earlier this year. Yeah, I play quite a lot of Nintendo, and I quite like Breath of the Wild. It's a very simple website because, as I said, my HTML isn't great. But what I'm doing here, I'm really proud of. I'm keeping my data stored in a third-party system. I'm using an API, pull it down, creating an HTML web page, pushing it up to S3, invalidating a CloudFront cache, and everyone can see my project. Total cost to me, about 3 cents per month for all the hosting costs, all the compute costs. This is really, really cheap for low volume. And that's all I want to talk to you about today. I want to have given you a flavour of what serverless is all about. I think serverless is the future. Key thing I think you need to take away are that serverless with PHP is just like writing normal PHP code. Although it's in a new environment, we are still building PHP. We're still doing good software engineering practices. We're still separating our code. We're still writing testable PHP applications. We are just hosting them on a very cost-effective, automatically scaled, and very cool platform. Thank you. Finish off, here's some resources. If you want to read up on this, acrobat.com is my website. If you've not come across serverless before, then Martin Fowler's website has got a good article on it. If you want to look at the source code for the 2 examples I showed you, they're on GitHub. And then if you want to know a little bit more about OpenWhisk or Lambda or Bref, those are the places to go. Thanks very much.